Proceed in pseudo calculus problems. Okay, so mind blowing discussion. We are making pseudo calculus problem. Actually, I was looking into a list of problems that are already available so that I can pick another one. Looks like all are very simple. I'll try sometime if I get other list of problems that are really extremely tedious that we can bring in. But idea is not to solve problem by problem. Anyway, we are solving problem by problem, that is true, but to give a channel, that in what channel someone should start thinking so that he shall be able to, means he can categorize the problem. Means, I mean, we are promoting anyone to solve a problem through its natural way, in his natural way, in her natural way. Whatever the natural way of a person, in that natural way only he should proceed upon solving the problem. Once he reaches a level where he feels that he is not able to do, then how he can switch into the calculus. So that arena we are talking. Anyway, now we are talking about the length of a stick. This example we have taken, that if I have a unit length stick, okay, consider this is a unit length stick, and this unit length stick I I make in two parts. Okay, this is the middle part. I can cut this I can cut this stick. Okay, I can cut this stick. Okay, it's really straight. I can cut this straight into two parts. Okay, where from I'll cut, that is whatever the God gives me instruction, from there I'll cut it. So where from I'll cut, I can cut from anywhere. This is a stick. What is the length of a stick? Length of a stick is 1 meter. The length of a stick is 1 meter. Consider. Now I'm going to break it into two parts. I cut from here, I cut from here, I cut from here, something like that. Like this, I have innumerous number of stick I have kept here. Innumerous number of stick. I pick one and then cut from anywhere. The longer part what I see, I throw it in one direction, and shorter part I just throw it away. Longer part I keep it, and shorter part I throw it away. I can cut it into two parts where the cut point can be at the middle, before the middle, and after the middle, because I have to keep the longest part. If I cut at the middle, any part I can take. But if I cut prior to the middle, then longest part I have to take. If I cut after the middle, then this longest part I have to take. If this is origin, if this is the origin, and if I cut after the half, then this is the, we consider this is as the x distance at which we have cut, where x can go from 0 to maximum 1, because distance is 1. But if I cut before the half, and this is the x distance from the origin, then we have to retain 1 minus x length of the stick. If I cut after the half, then I have to retain x length of the stick, because this is the longer one. If I cut prior to the middle, up till here, from here till here, if I cut, then this part I have to throw out, longer part I have to keep. That is 1 minus x. 1 minus x I have to keep if I cut prior to the middle, and x I have to keep cut if I cut after the middle. X and 1 minus x. Okay, if this is a scenario x and 1 minus x, now I just keep out the longer part. Now I have so many longer part collected. Okay, that length is half to full, because I am taking longer part, right? So longer part cannot be less than half. It will start from half, and it will start from the half length, and it will go still full length. Okay, that is the longer, that is the stick. Now what is the average length of the stick? That is under question mark. If I'm trying to find average length of the stick, then we have seen through digital way, discrete way, how I can find the average length of the stick. And through that average length discrete way. What is discrete way? I divide this stick into n part. I divide this stick into n part. Now, if I divide this stick into n part, what are the n part? N part is 1, 2, 3, 4, ith part and then nth part. There are n part of the stick that I can see. If I make a cut, then cut will go to any of the part. Make sense? If I divide a stick into n number of parts, first part, second part, third part, fourth part, fifth part, like n number of parts, in that fashion, if I make a cut, it will fall on any ith part, where I start from here, first part, this is origin. Okay, what is the length that I am keeping? If I is here, ith part is here, then from origin it is I into 1 by n, because one part is 1 by n gap, 1 by n gap, 1 by n gap, 1 by n. The width of one part is 1 by n, where 1 is the length of the stick 1 and n is number of sections we are making it. Each section length is 1 by n. Ith section length is I into 1 by n. If ith section crosses the half, that is n by 2, then the length I am keeping is I by n. But if ith section is before the half, the length I am keeping is the right side, that is 1 minus I by n. That is clear. Okay, next we saw that what is the probability that I make a cut in any of the part. N parts are there. I make any of the part. What is the probability of hitting that particular part? Any part probability is same, that is 1 by n. If there are n sections, hitting into any particular section, the probability is 1 by n, because probability is same and there are n sections, that 1 by n. Okay, means I can say that probability mass function. There is something called probability mass function. Probability mass function means that now I can draw a height chart. If this is the x-axis, then this is y-axis. This is probability mass function. This is x-axis. This is y-axis. What is y-axis? Now, and in every gap, in every section, there are n sections. In every section, I draw a bar. In every section, I draw a vertical bar. What is the height of the bar? That is 1 by n, and that is the probability. N by n is the probability. What is the n by n is the probability? What is the height? We have taken a simple example some time back. Means in a class there are, I am repeating it again, in a class there are 10 students, and 10 students in examination they are securing marks. How many marks they secured in the examination? When there are 10 students, then 4 students are securing 50 marks, one student is securing 70 marks, 3 students are securing 60 marks, and 2 students are securing 40 marks. If this is x-axis, then x-axis length is 0 to 100, that is the marks. Each section is of 1 unit. I have chopped it into 100 sections. Now, in the 50th section, we have a bar. That is how many students they have secured 50 marks. This axis is for marks and vertical axis is for number of students. Then at 50, number of students is 4. What is the probability mass function? Mass function means what is the probability function there? Then it is 4 by 10, because 10 students are there. At 50, the height is 4 by 10. At 60, height is 3 by 10. At 70, height is 1 by 10. And at 40, height is 2 by 10. What is the average mark students have got? The average mark is distance from the origin. That is the marks into its density. This is or probability mass function or density. Density at the marks 40 is 2 by 10. 2 by 10 into 40 plus at 50 it is 4 by 10. 50 into 4 by 10 plus at 60 it is 3 by 10. 60 into 3 by 10 plus at 70 it is 1 by 10 plus 70 into 1 by 10. Just solve it. This will give the average marks of the class. Similarly, if we have divided into n sections, in marks we have divided into 100 sections. Here we have divided into n section. If we have divided into n section, The probability mass for each section is 1 by n. If I'm trying to calculate the average length, then it is the length into the probability mass function. If I multiply, I get the weight of this length. Everywhere length has a weight. Like in mark section, every marks has a weight. The 40 marks has a weight of 2 by 10. 50 mark has a weight of 4 by 10. 60 mark has a weight of 3 by 10. And 70 mark has a weight of 1 by 10. The weight into marks give the net marks at that point. Or, okay, weight or density. I believe this is a better word. At 40, the density is 2 by 10. Density into marks will give the net weight, that is the better one. If this axis is marks axis, at each marks we have density. Density. Okay, if full x-axis is of same density and I'm trying to calculate the weight, I can multiply this density into the length. Makes sense? Consider I have a length of a stick is 100 and I know what is the density. Okay, density, that is per meter. Density into length is the net weight. Similarly, if I have a stick and everywhere density is different, at 40 marks, density is 1 2 by 10. At 50 marks, the density or density I can describe as a height also. Density is 4 by 10, 3 by 10, 1 by 10. Okay, otherwise 0. There is no density. What is the weight? Then 40 into the density. The density is how density is how many students. Whereas this is the marks and how many students. If I multiply, then I get the net weight of these marks. 40 marks, if density is 1 by 10, the net weight of this mark is 40 into 1 by 10. Okay, in that fashion, if I add all the multiplication, I get the net marks. Okay, that is the scenario. Number of students in a particular mark. Number of students at a particular mark. Okay, number of students at particular mark. If I multiply by the mark, if I multiply by the marks, number of students, 40 students at, I'm sorry, 1 by 10, I'm sorry, 2 by 10 students, 2 by 10 number of students at 40 marks. If I multiply a student into marks, I get the net weight of that marks in the final calculation of the marks. If I add all with the probability density, not normal density. Normal density is 2, 4, 3, and 1. Probability density is 2 by 10, 4 by 10, 3 by 10, 1 by 10. If I multiply with the marks and add it, I get the average mark. We are trying to calculate the average length of the stick. That is the question now. Average length of the stick, to get it, the length of the stick into its probability density. Probability density is 1 by n and length is I by n. If I multiply, I get the weight of this length plus weight of this length. Now I is varying from 1 to n. Okay, weight of each I is how much? I into the vertical bar, that is probability, that is 1 by n, constant for all the sections. Okay, so then what is the average length? Average length is summation I equal to 1 to n, I by n, that is the length from the origin, into 1 by n. But problem here is that if we are breaking after the half, then I take as I. But if I breaking before the half, then I take 1 minus I by n. Now I break it. Now it is summation I equal to 1 to n minus 1. Sorry, to n by 2. And then it is 1 minus I by n bracket into 1 by n. That is the average length of the stick. If I cut it before the half, okay, if I cut here, then rather than taking I by n as the length, I am taking 1 minus I by n as the length. This side I am taking, other side. So it is summation I equal to 1 to n by 2, 1 minus I by n bracket 1 by n. This is the, if the breaking is before the middle. If breaking is after the middle, then full length I can take. Another is summation I equal to n by 2 plus 1 after the half. N by 2 plus 1 up till n. I by n into 1 by n, that is the word. If I sum it, then I get the average length. We have done for many times, many ways. If n equal to 4, n equal to 8, n equal to 16. Anyway, the question is arising that can we compute into a continuous manner, not into discrete manner. Discrete means I divide the stick into n parts, but n can be anything. No, so this is not satisfiable. We came answer was 3 by 4. But anyway, through discrete way, through analogous way, can be computed. What is analogous way? Analogous way is in a form of fx dx. This is called analogous way. Fx dx. If I have any function f, if I have any function f, then fx dx terminology calculate the area underneath it. Okay, that is the integration. Integration will come into fx dx. Simple. Fx into dx, integration limit of dx, the x inside d is x, lower limit to higher limit. This is a normal form of integral calculus where fx is a function over x and it is continuous. Makes sense? If this is x-axis where x is going from 0, if this is x-axis, hope, I am going to make it straight now. Okay, consider this is x-axis and this is 0 and this is 1. That is the length of the stick. At any moment, we are at x distance from the origin. Now, there is another function on top of it. Consider this is x-axis. This is 0 and this is 1. That is the length of the stick. And there is a function over it, fx. Function is continuous and it spans from origin to any distance 1. It spans after that also, or it spans before the origin also. What is fx dx? If I say fx, this is function fx. At any moment in x, any moment, 1.000001, any moment in the x, I have a fx. Fx means vertical, x means horizontal, and function over x means vertical. So at any moment of x, I have fx. That is the vertical. If I draw a vertical line, it will hit at this point. That is the length of the fx. At any moment x, I have fx. If I say fx dx, where x limit of x is from 0 to 1, then it will calculate area underneath this function. If I draw like this, then fx ds will calculate the area underneath. Consider this function fx. We are talking in a straight line. Consider this is a straight line. Then if I talk about area, then this area will be a rectangle, because at the origin this will be a straight line, and at x equal to 1 this will be a straight line. This will make a rectangle. And area fx dx, where x equal to 0 to 1, will give an area of rectangle. If I say fx dx, where this is the fx, then it will give the area underneath. This is not rectangle. If I touch like this and say this is my fx, then this is a kind of a circle arc or something like that. Area underneath it, fx dx. Can I compute our problem as fx dx? That is the question that is arising. What is fx here? Fx is probability. Fx is probability, means fx is height. If I have a stick, if I have a stick, if I have a stick and length, it is going from to distance, any distance x, maximum it will go up to 1. What is probability here? At any, what is the probability? Probability of cutting any point. If I cut at any point x, what is the probability cutting at any point x? Consider this probability is fx. Any point, the height we talk about probability, right? Any point it is fx. Any point it is fx. If I saw the marks, this is the, consider this axis is marks axis, and this is 0 and this is 100. I consider I make a cut at any point. If I make a cut at integer points 1, 2, 3, 4, not at 1.5 or 1.7, because consider a student is getting marks in integer only. Either he is getting 40, 41, 42, 43, 44, like that. If that is the way, then if I make a cut at anywhere, then what is the probability of that point? If cut I made by chance at 60, then at that time fx is 3 by 10. If I make a cut at 70, then fx is 1 by 10. If I make a cut at 50, then fx is 4 by 10. If I cut at 40, then fx is 2 by 10. If I make a cut at any other place, fx is not there, 0. Okay, in that fashion, adding all will give the fx at x equal to 40, 50, 60, and 70. Fx into x into fx will give me the summation I equal to 1 to 4 will give me the net average marks. Similarly, now consider the student is getting marks in any fraction. He may get marks as 20.33, means student get marks anywhere. Now I have to make infinite cut. If there is 100 marks, then I made 100 cut, one number. Consider student will get any point mark also. 20.333 is his marks. Okay, in that fashion, I have to consider a height chart that will be continuous, not discrete at a single point. What will be that height chart? That is under question mark. This is also called probability density function. Probability density function means if I have number, if then what is the average? Now consider that the student is getting, there are 10 students. Okay, I believe that will be complex. Let's go back to the stick example. Now, stick example, there is a chance that a person would cut at any moment. Earlier example we took, that person can make at only 10 points. If I divide, I'm sorry, only at n point. If I divide the stick into 0 to n, then only at n different point anyone can make cut. In a particular section, he cannot cut at two different points. He can cut at only one point in one section. And there are probability mass function at every point. Like in marks, a student will get marks only one in one section, that is 50 to 51. Everyone will get either 50 or 51 or 52. Means one section, one bar will be there, one height will be there, that how many students are there. Okay, similarly, if I make n section in this line, then in every section, there will be one bar there. Now I can take n tends to infinity, that we have done in the past video. What about if n tends to infinity? Then it may lead into continuous function. Let's take continuous function all alone only from the other side. If I take continuous function, what is the characteristic? Consider this is x-axis, and at any moment the cutting it, the chance is fx, probability is fx. This is called probability density function. Is it 1 by n? That is a question mark. Consider I divide this section into n part and n tends to infinity. Then it will come to a continuous manner, right? If I divide any line into n part and n tends to infinity, more or less it is like a very fine. What will be the height of at each point? The height of each point will be again 1 by n, 1 by n, because chance of cutting at any point is 1 by n as per the fundamental. What about continuous function called fx? If I take x length from here, what is fx? What is characteristics of probability? This we need to understand first. If I draw a probability graph here, that any point, what is the probability? At any point, what is the probability? Continuous probability graph it is related to discrete graph. Discrete graph means every moment we have a height. They are not touching each other. In every section there is one height. You can make section width as very small, tends to 0. That is true. But we divide it into section part. Discrete methodology, it talks about cutting anything into different sections. When number of section is n, where n tends to infinity, and that will turn it to integral calculus. We have described very nicely in the previous video. What about n? And then n, if I take n, then our solution is summation I equal to 1 to n by 2, 1 minus I by n bracket into 1 by n, plus summation I equal to n by 2 plus 1 to 1 I by n by 2 n by 2 to n by 2 plus 1 to n I by n into 1 by n. Consider n tends to infinity. Then we saw how I can convert it into integral calculus. Then it will be a smooth curve. Let's take a smooth curve at all, completely. Let's take a smooth curve. If there is a smooth curve, and that is called probability curve, what is the definition of probability? If there is a smooth curve, the definition of probability is that if there is a smooth curve of probability, that is called fx, then fx is the height into the fx is the probability height, and this is the x. If I multiply this into the height, it will give me the net probability along this period. What is the net probability along this period? If I calculate the multiplication, I am not talking about the area. If I calculate the net multiplication, then it will give me the net probability. Net probability for the full duration is 1. How it is 1? Consider there is a dice, there is a dice, and dice, there are two dice. One dice is 1 to 6. Now if I roll it, what is the probability? I believe it will be difficult. Consider that there are three coins. There are three coins, and then I am throwing it in random. What is the probability that there will not be any head? Head equal to 0. Now here we are, head equal to 0. What is the probability that there will not be any head? The probability of not getting any head, someone can compute how much. If consider if there are two coins, then probability of not getting any head when I toss two coins together, that is 1 by 4. What is the probability of getting one head? That is 1 by 2. What is the probability of getting two head? That is 1 by 4 again. Then I draw a chart. At 0, it is 1 by 2. At 1, at 0 it is 1 by 4. At 1 it is 1 by 2. And at 2 it is 1 by 4 again. Means at the middle it is high. Okay, this is the probability graph. But what is the requirement for this graph? If I calculate the area, it should come to 1. The net probability, if I sum 1 by 4 plus 1 by 2 plus 1 by 4, it must be 1. That is the requirement. Makes sense? If I throw a dice, what is the probability that it will be 1? Dice is, I believe, 1 to 6. Then at 1 probability is 1 by 6. At 2 probability is 1 by 6. At 3 probability is 1 by 6. At 4 probability is 1 by 6. At 5 probability is 1 by 6. At 6 probability is 1 by 6. If I add all heights, if I add all the bar, it must sum it to 1. That is the requirement. All probability must sum it to 1. What we are seeing here, people will understand, okay, I understand if I roll a dice, then all probability, if I sum, it becomes 1. That is true. But if I draw in graph, if person watches very carefully, then he is drawing 1 by 6 height at this is origin. This is 1, then it is 1 by 6. This is 2, then again 1 by 6. This is 3, again 1 by 6. If he is calculating all the height, then it is 1 by 6 plus 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 1 by 6. Okay, this is what it is. Now, if he is calculating, 1 plus 6, 1 by 6, 1 by 6, he can write is summation I equal to 1 to 6, 1 by 6, or the probability of the ith time, probability P subscript I, probability of the ith draw, summation I equal to 1 to 6, probability of the ith draw. If I, what is hidden here? Hidden is I can write 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 6 times as 1 by 6 into 1. Makes sense? 1 by 6 into 1 plus 1 by 6 into 1. What is 1 here? The hidden 1 is the width. Okay, if this is 1, if this is 0 and this is 1, then width is 1. At 1, I am taking height as 1 by 6. 1 by 6 into 1, it is giving me area, if someone don't mind it. Knowingly, unknowingly. If width is 1, if width is 1, then height is 1 by 6. If I multiply this height with the 1, it gives me the area. Area is 1 by 6. Someone is saying bar height is 1 by 6. No, area is 1 by 6. Anyone would fight. Area is 1 by 6. This is the area 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 1 by 6. This is area 1 by 6. What is your fx? Fx means at every point, what is the fx means height. What is the height? 1 by 6, constant. I know, understand. Then you are describing it as fx becomes area of that section. Area of that. If I add all area of that section, it gives me the full area. Full area is nothing but fx dx as per the calculus fundamental. Full area. If I have one area, continuous area, if I have one vertical area, then continuous, next non-overlapping. If I have a vertical area, then next area, then next area, then next area. If I combine, I get a continuous full area. If I connect the top part and consider it is fx, then fx dx is the net area. Okay, and this is also net area. Okay, means that net area. No. I don't know about a net area. But if I draw a probability graph where each point I have probability, what about the coin? If I have two coins, when it is 0, then probability is 1 by 4. When it is 1, then probability is 1 by 2. When it is two head, probability is 1 by 4. 1 by 4 again. 1 by 2 is high, 1 by 4 is low. Now, if I add all three, it becomes 1. Or we can say that if I say at head count equal to 0, the probability is 1 by 4. 1 by 4 into 1. Actually, it is 1 by 4 into 1. Someone can consider this is area. Then 1 by 2 into 1. This is the area. Then 1 by 4 into 1. This is the area. If I add all three area, then it becomes 1. Rather than saying adding all three probability, it becomes 1. I can say adding all three area becomes 1. Then it is fx dx. Then what do you want to say? I am trying to say if you draw a probability continuous function, and if you calculate area from the begin point to end point, it must be 1. Makes sense? Okay, means if I draw out not a continuous function, vertical bar as probability, and then if I calculate all the vertical bar, it must be 1 because net probability is 1 because it will give you the sample space. If you add all possible probability, then it will come to a sample space, and sample space probability is 1 only. Means if I have x-axis and if I'm trying to draw a continuous graph of probability, then I area underneath, that is the summation of all the bar actually, indirectly, it should bring the 1. Or if I have a continuous function and if I divide continuous function into many chop, each area, each area will say I have one continuous, one distinct bar. Okay, adding all the bar gives 1. Then we saw that one bar, if I have one bar into area as width as 1, gives that area subsection of the full area. Means if I have a probability density function, then area underneath from beginning to end must be 1. Full probability means the probability addition of all the possible outcomes. If I am rolling a dice, then adding probability of all possible outcomes should be 1. Means if I draw a probability continuous graph, area underneath must be 1. Okay, in that fashion, now let's take our stick example again. Okay, in our stick example, if I have length 0 to 1, and then if I draw a graph, then what is the equation of graph where if I calculate the area, then it should be 1. The idea is 1 equal to integration of fx dx, 0 to 1 should be 1, then it will be 1. Fx should be 1. 1 dx means x, 0 to 1 means 1. Makes sense? Now we have that is 1. Means if I draw a continuous graph of fx equal to 1, everywhere it is 1, only height is fixed 1. This will denote the exact continuous probability graph of the stick cutting. Anyone would be surprised. Isn't it like that? If I make n different cut, then probability bar height, discrete probability bar height is 1 by n. But if I make a continuous cut, then where from origin at any distance x, if I make a continuous cut, then probability continuous function height is 1. 1, 1, 1, not 1 by n or something like that. It is 1. Okay, what about the length of this stick is 2. Length of this stick is 2. Can someone answer what is fx now? The net area underneath must be 1 only. 1 equal to integration x equal to 0 to 2 fx dx. Now in that fashion, fx I have to take 1 by 2. 1 by 2 fx, 1 by 2 dx will be 1 by 2 x, and then 0 to 2 it will bring 1 only. Means fx will be half if it is going from 0 to this. This is called typically uniform distribution in probability. It has uniform distribution. Now right now for our stick example, 0 to 1 length, the continuous function as a function equal to 1. If that is the case, let's proceed. What is the average length? Average length, if I talk, then whatever the density function height is, multiplied by this length will give the weightage at that. If I have a density probability function and multiply by x, it will give me the weight at that moment. If I add all the weights, I get the net length. Makes sense? The way we did in student section. The marks into probability density will give the net weight. So in that fashion, here also we have to do what is the probability density here? fx 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 dx. Hop. It is fx dx, not only fx. I cannot say integration x into fx will give me the result. Integration of x into fx dx. Okay, because fx is a density that must be multiplied by some dx, and then in that fashion it will give the actual probability. So it is, I believe it is understandable. If I say fx dx and it goes from 0 to 1, it must be 1. If I say, okay, then can you convert it back into digital? Anyone would ask. If you have a fx function, if you have a fx function, then can you convert back into digital? I can convert. Fx is probability density, right? Fx into the width will give me a bar. If there is, consider there I'm chopping it into n part, then whatever the fx at a particular point into 1 by n. If I have x axis and this is 0 to 1 as in our stick example, if I divide into n part, then at any moment what is the height, that is fx. Okay, fx into one section, that width is 1 by n. Integration, I would repeat it again. Consider this is a line, and line is divided into n part. Consider this is the ith part. If it is ith part, then this point is I by n, and this point is I by n plus 1. I by n, if this is the first part, second part, n part. From here to here, the length is I by n. And the next, if I take one section, at the boundary of the next section, this length from here is I by I. It is, I'm sorry, it is first is I by n. The length is I by n. Next is I plus 1 by n. Next is I plus 1 by n. So that is the width of this. Now if I have fx, I can say fx dx, where x is from I by n to I plus 1 by n. If I compute it, then it will give me the probability mass function, the height function in that section. Makes sense? If it is 1, If it is 1, then let's compute it. If it is 1, then 1 dx, it will become x. It will become x. I by n to I plus 1 by n. It will become I plus 1 by n minus I by n. It will become 1 by n. This is what we took in discrete manner. Every section, the probability height is 1 by n. Make sense? Okay, but if we take in continuous manner, and if I want to get, consider it is delta x, instead of we say that we chopped into many parts, whatever it is. If the width is delta x and height is fx, then bar is fx dx. Means for this small section, the area is fx dx. Now this area or this bar, if I multiply with the x and add it, I get the net average. This is a $1 trillion explanation. Now we have for each section that is divided into delta x, delta x, delta x, delta x. Each section, the probability density is fx dx multiplied by x will give the weightage of the x at that section. Like that, I have to add for all. More or less, it will come into integral form x into fx dx. Someone can understand other way also. X into fx is gx. X into fx is gx, which gives the another function gx dx. It will give another area. So if I have fx as probability density function as continuous, multiplying with the x will give me another function, and that is gx and dx. Anyway, we are not taking that. Right now we are taking x into fx dx and integration from one limit to another limit. But problem here is this x will change now. If it is before n by 2, then we have to, if I cut before n by 2, if x from the origin is below less than n by 2, if this anywhere I am cutting, I have to take the bigger half. Then it is 1 by x I have to take. Now integration will be divided into two parts. Integration x equal to 0 to 1 by 2. 1 minus x, the distance, the length we are taking, length into probability density will give the weight of that length. If I am taking length as x and x is falling before n by 2, the length I have to take is as 1 by x. This into probability density will give the weightage of this length. When we are calculating mean, what is mean? When we calculate mean of length, if I have so many sticks, what is the mean of this length? Anyone would ask. If I have so many sticks, consider I have innumerous number of sticks that is kept. Now I have to calculate the mean of this. Anyone would start counting, measuring the length of the stick one by one. A clever person would think that in what is the kind of I would rephrase it. Consider there are so many sticks are kept. What is the average length of the stick that anyone would see? Okay, then any clever person would think now that stick is starts from the half meter and it goes till 1 meter. What he would do is it will divide half to 1, or he will divide 1 meter into 10 sections. One section width is 1 by 10. Now he will divide all the sticks into 5 different parts. One stick that is of length that goes from zero point 0.5 meter to 0.6 meter, all the stick in that section. And then 0.6 meter to zero point 0.7 meter, zero point 0.7 meter to 0.8 meter, 0.8 meter to 0.9 meter, and 0.9 meter to 1 meter, all in different sections. Okay, and then he will just count it. Now for the section 0.5 to 0.6, he knows there are some number of stick alpha into zero point 0.5 or 0.55, whatever he thinks, plus another one is beta. It is far easy than calculate one by one. In similar fashion, if I take the integration, then if I am cutting before it, then I have to take this section, longer section. Longer section is 1 by x. If this is x, then this is 1 by x. Now it will come as x equal to 0 to 1 by 2. X is 0 to 1 by 2. If it is like that, then the length I have to take, because this length will be multiplied with the density to have the weightage of the length, because this stick is going to get collected, not the smaller part. Even though it is at x length, 1 minus x will go and get collected. But anyway, since we have made a two section in our integration, the actual mean length is integration 0 to 1 x fx dx. That is the actual calculation. Okay, fx, I know it is always 1. Probability is always 1. X into dx. But x is not same. Where x, what we are saying, is not x from the origin. X is the length of this stick. That someone has to understand. So when it is kind of x is prior to origin, then what length we have to take is 1 minus x. That is the actual length. I mean, x is from here only, but length I have to take. So if I say x fx dx, integration of x is from one to another. The first x we are seeing inside it, actually it is the length. And next fx dx, what we are seeing, it is the actually density. Density into length will give the weightage of the length in the calculation of the summation. Okay, so first when x is 0 to 1 by 2, it will be 1 minus x, because that is the length we are taking. Fx dx, it will be 1 minus x dx, integration 0 to 1 by 2, plus integration 1 by 2 to 1 x dx. If I cut after that, this x will be taken into the picture. Okay, we have done this calculation and it came as 3 by 8 plus 3 by 8, 3 by 4. This is the best solution. Rather than dividing into n part and then calculating for a particular part, this is the better solution. For this solution, if I draw a fx, then precondition is fx integration over a full limit will give the net sample space, outcome of addition of all outcomes. Addition of all outcomes. In that fashion, it must be 1. In that fashion, we thought that fx should be 1. Then we proceeded and we calculated the average length of the larger stick is indeed 3 by 4. We will talk little more about it, and then we'll have little more about the area calculation of the circle. These expressions are not available in any of the book. Please do not mind supporting us. Plus 91 is the India country code, 9483160610 is the telephone number. Plus 91 is the India country code, 9483160610 is the telephone number. Okay, so war